Yeah, so we want to look at the second research tool that we have here. Now, we dealt with the OLS series regression. Now, let us look at the dynamic OLS. Yeah, dynamic OLS. We click to open it, and before we wait for the form to come out, yeah, it takes time for them to initiate, but not too long to come out. Yeah, it's now out. Same thing that happened to DOLS is also happening here. We have the two time interval variables and variable groups boxes here disabled or deactivated because they are not needed, but we still do the same thing with that. Now let us just even use what we have before. Okay, let's use the same meal. Sometimes Excel file to do this analysis. Now, the dependent variable is meal. We move on to the independent variable. This time around, let us increase this in ing 1, comma, ing 2, comma, ing 3, comma. Then let's now add egg, SES, and probably, okay, we have 5 now. Okay, probably we can now add oil. So, and then we now move on. Remember what we did? We are only separating each of these dependent variable, independent variable. That's the predictor variable with just comma, no space. So better remember that. Then after this, we now have we have to jump the disabled fields, the time interval and variable groups, something, and then we jump it to the name of the data set. Now the name of the data set, we are going to use the same data set we use for the OLS. Now let's see SUMTAS, and then we click okay, yeah. Now you can see this one automatically just pops up the plots. This is the first one is a box plot. That's the one that first pops up. Then yeah, now this one is a line graph. And this line graph is just based on the way the data was there. So that is why it is just like this, like jaga jaga. So now, yeah, this is a better one. You can see most of all these are barely visible. Most of this they are barely visible because of the value that they have. So, and then I believe that's the end of the plot. So let's now look at the result on the screen. The result on the screen, as before, it shows the data set used. Shows the data set used and the number. Okay, let me pull it out so that we can see it better. So, and the number used is 40. Remember, it start numbering from 0. Yeah, you can see it start numbering from 0. These are these. The variable names that are used. Well, now let's look at the output. Now, we first start with OLS regression results. just like that. Remember what we are doing is dynamic OLS. So the results may be a bit different, but not too different. The dynamic one has its own advantage. Now let's look at it. So the omnibus 4.0 probability of omnibus is this. Then the skewness, W1C, and so on and so forth, they're all there. Then note the standard errors assume that /-- then test statistics is this. P-value is 0.00, which means that it is very significant. Then of course we also have the variance inflation factors for multicollinearity, and then it's telling us that the analysis results are contained in C, so and so. So that's it. So that is for the DOLS results. If you look very well, you find out that you are going to see the difference between this one and the other one that was made. But whatever it is, I mean, as for the objective of this is to show you how to use the VSP to run your data. Maybe much later we can produce a video that will also teach you how to interpret them. So as before, you also have this. Now, this is DOLS graph. You can see what was shown us before. See what is on the floor, and then the line graph, the one that was a bit funny. Yeah, the same thing that was shown before, still there. Then the box plots, yeah, same thing as shown before. Now let's look at the result itself, the one that just like what we have in the other one. This is also the result, and it's also printable. Yeah, so that's it. Okay, so that's about this. Now let's see if we can do another analysis. Yeah, so we can do another analysis. Let's call up the program again. Yeah, so it's starting up, and then we also go to the research data analysis menu. We open it. Now, well, let us just try our hands on the full panel and see what happens. we are going to use the same meal something because it has time and group. So let's see what happens. Okay. Yeah, you can now see in this one that all the boxes are activated. There's no one that is disabled. So now let us even look at the data set we want to use and see what really we are looking for there. Let's use the Sumtas Sumtas, okay. Now let's see and let's look at it and see the one that, okay, we have, yeah, the time period, the time is period, then we have firm, okay, good. We have firm as the company ID. You can even type the names of the companies if this is a real, data distance. But here we maintain coil 1, coil 2, coil up to that is, and each of them has, I think 5 years period. Okay, this is going to be a good measure of a good analysis if we'll be able to remember exactly what we have. But let's open this so that let's keep it open so that we can remember what we are talking about. Now let us now enter. The dependent variable name here is meal. Now, the independent variable names, we can even choose all of them. We can, like egg, comma, sal, comma, SES, comma, oil, comma, ing1, comma, ing2, comma, ing3. Yeah, so all of them have been entered up to ing3. So now already is suggesting a period here. We have a period here, the period which is the time interval. So we leave the period there. If it is not period that we use in saving that time interval, we can put whatever we use to save it, but we use period here. And then the firm column head or entity names. Yeah, we have the column head here as a firm. You can see the period 2019 to 2023, and then 2019, just like that. They have the firm, coil 1, and so on and so forth. The entity, the column head for entity is firm. Now, the name for the data set is called Sumtas. That's the name. The same name we have been using to do other analysis. We want to use it to do the panel regression analysis. Why? Because it also has the properties that can be used for panel. That it has time and also has entity names. So now, let us go. So that is it. This is it. That's the panel. Okay, VSP statistical package data set used. We use the same just for that 40 observations. We use just 40 observations for it. Now this is the panel OLS estimation. The dependent variable here is meal. Estimator is panel OLS. Number of observation is 40. Date is Wednesday, July 10, 2024. Time is 17:42. Estimator is robust. Good. And then R squared here is minus 0.0302. R squared between 0.704. Then R squared within 0.14. Then R squared overall minus 0.2010. Then log likelihood is minus 130. F statistics is minus 0.10. Then p-value is 1.000, which means that it is not in any way significant. Then distribution is F622. That is it. That is the distribution. That's degree of freedom. F statistics is 6.92. Then p-value is 0.003, which means that this thing is that is the distribution itself is significant. That is model is significant based on what it is. Then that's it. So now let us now scroll further and then see other results. Now other results. Time periods, observation is 8.00. The minimum observation 8.00, maximum observation 8.00, which means there's no loss of data there. Then parameter estimates, you have for all of them, you have egg, cell, SES, O, that's oil, ING1, ING2, and ING3. Look at their parameter, look at the standard error, look at the T statistics, and look at the p-value. Well, as usual, none of them, okay, except the only one that was significant is oil, looking at the p-value. So, and that's that. Then lower CI and upper CI, you can see it there. Now, the F test for pullability is 0.5419. The p-value is 0.85, which is not significant. And then, of course, the distribution is that is the DF, degree of freedom, is F1122. Included effects are entity and time. Good. And then random effects are results. Random effect results is here. R squared, this, and parameter estimate. Yeah. So now, one thing we need to understand here is that we did both. That is this. This particular VSP did for both random effects and the fixed effect. The first one that we read out is the fixed effects, and then the second one now is the random effects. That is the second result that is here. So it's now left for you now to take the one that you think is much more useful to you. You can see the random effects the degree of freedoms are different. 633, the other one is 622. And of course, many other things that are there. Now, the parameter estimates also differ, but I think oil also was significant in the random effect test. Then Houseman's specification test compares both the fixed effect and the random effect. Now, the dependent variable for both of them is this, and then the fixed effect used panel OLS, which is the first one we did, and then the number of observations is 40, and the estimator is covariance estimator is robust, and then the R squared, and so on and so forth. So now these are other diagnostics texts: the egg, the SAL, the SES, the oil, and so on and so forth. The effects are entity and time, and then T stats reported in parentheses. T stats are reported in parentheses. Okay. And then the output of this is also given in this. I'm not too sure that this one also, no, this didn't produce any graph. It is because it's not necessary here in the panel OLS. But this is a very robust result. If actual data had been used, it would have given us a very, very satisfying result of the relationship in accordance with the panel. So we thank that is and that, and then just like it is also showing us that we can also get this result from the panel results in the value start folder. Now let's look at the value start folder and see whether this is so. Yeah, let's look at the okay, that's the panel results. Now let's see. That's it. So the fixed effect is the first one, the panel OLS, and then the random effect is the second one. So just like I said, you don't need to start going to beat your head or beat about the bush about this. All you need, you have the two results for the fixed effect and for the random effect all together. And then you now choose the one that you want to use based on your preferences and based on what the comparison of the fixed effect and the random effect has given to you. You can see that there is a comparison here of the model, both the fixed effect and the random effect. So this is the most advanced panel regression analysis that you can get, now. Yeah, I believe this has been very, very educative enough. Yeah, thank you.